So today we'll be discussing on how to cut a spur gear using a universal milling machine. So as we all know, milling operation is actually an intermittent cutting operation that is used to remove the workpiece material effectively using a rotating multi-point cutter. So some of the basic advantages of using the milling machine are that it provides excellent surface finish as well as accuracy. Now we'll discuss some important types of milling machines. So first is a column and knee type milling machine. The next one is a fixed type milling machine, and we also have some more types of milling machines like the planar type milling machine as well as the special purpose milling machines.
So we are discussing about the universal milling machine. This is a universal milling machine. It's a kind of column and knee type milling machine. Its make is Batley Boy, India. Now we are discussing about the parts of the milling machine. It has a base. This is the base and it carries all other parts of the machine and has a vertical column. This is the vertical column, and the vertical column carries all other driving mechanism of the milling machine and has a gateways. In gateways, the knee is moving. This is the knee, and it also have an overhanging beam. This is the overhanging beam. This overhanging beam carries a arbor which is connected to the spindle, which also carried by the housing. Again, there is a cutting tool. This is a multi-point cutting tool. This is a module cutter, and this performing the metal removing operation.
Discuss about the knee movement. So as we all know, the knee is moving along the linear guides. So the knee movement is possible by rotating this wheel along the Z direction. So this is the way we can adjust the knee movement. Now here we have the bed. So the bed, as we know, can move in 4 directions. So one is a X direction. So X direction is operated by the wheel along that side. Now the bed can also move along the Y direction. So the Y direction movement is controlled by this wheel. Now it can also move along Z direction as well as along an angle. That is, rotational movement is also, an angular movement is also possible for the bed. We will see the chuck of the milling machine, universal milling machine. So this is the chuck of the universal milling machine. So in this chuck we will be holding the mandrel, and on top of that we will holding the workpiece. So this is a tailstock that is used to support the mandrel as well as the workpiece.
So we are in the calculation phase. We know that our module of the cutter is 1.5. So we have to find out the outside diameter of the workpiece. For that, this is the workpiece. This is the blank, and this blank is fixed to a mandrel, and this is already made up of a lathe machine. And for measuring, we can use a vernier caliper. From the measurement, we will get the outside diameter of the workpiece is 48. And for find out the number of divisions, we have an equation: outside diameter is equal to number of divisions plus 2 into module. From that equation, by substituting values to that equation, we will get number of divisions is equal to 30. Again, next step is find out the index crank movement. We are using simple indexing. We already discussed there are different types of indexing: simple indexing, direct indexing, and compound indexing. For simple indexing, the equation is 40 divided by n. Here we know that n is equal to 30, and 40 divided by n is equal to, we will get 1 by 3, and this value should be applied to the crank, applied to the indexing mechanism. So we will get the index crank movement. So next step is find out the depth of cut. For that, we have an equation: depth of cut is equal to 2.4 into module. So when we are substituting the value of the module to the equation, we will get depth of cut is 3.37 mm.
Now we'll be discussing about the indexing mechanism in the universal milling machine. As we know, indexing is done to divide the periphery of the workpiece into equal parts. So now we have 3 types of indexing mechanisms. First is a symbol type indexing mechanism. Next is a direct type. And we also have one another indexing mechanism, which is a compound type indexing mechanism. So in this case, we'll go for the symbol type indexing mechanism. So this is the indexing plate which is available to us, and this is the indexing crank. Now indexing plate has equally spaced concentric holes along it. Now these are the scales that correspond to the equally spaced holes. So from the calculations we have done earlier, so depending upon the indexing value, we'll select a scale. So since our indexing value was 1 by 3, we'll select a multiple of 3. So in this scale, we can observe that 18 is a multiple of 3. So we'll place the indexing crank over here, and then we'll give a rotation of 1 by 3. So first we'll give a rotation like this, and then we'll go for 1 by 3rd of the rotation. And based on this, the rotation will be transmitted to the job. This is how indexing is being done. So as we can see here, the workpiece is being tightened and it is attached between the chuck and the tailstock. So as we can see here, the workpiece is being tightened and it is attached between the chuck and the tailstock. So now we are going to start the machine. So we can start like this. So by rotating the wheel, we'll make it in a just touching position, so that it will only slightly touch the workpiece, top of the workpiece. As we can observe here, the cutter has just touched the workpiece. Now we'll be giving the depth of cut based on the value we have calculated from the equation. So our depth of cut value was 3.37 mm. So since it is an intermittent cutting operation, we can't give 3.37 as a whole. So initially we will be giving 1.5 mm depth of cut by rotating this wheel. We will be starting the cutting operation. Here we have completed one cut. Now we will go for the indexing. So here, as we know, the value we calculated was 1 by 3. So based on that, first we'll rotate the crank once and then give 1 by 3rd of a rotation again. So this is how indexing is done. Now we'll go for the repeated cuts. So once we have completed all the processes, this is the final product that we obtain.